So we were discussing this topic of IP addressing, and um, basically we after building an introductory notion of what IP addresses are, we saw the some examples and the technique of classful addressing, which was being in use for the early part of the internet evolution. Uh, when devices started IP addresses started to get assigned to the devices, and after that obviously there were serious problems with the rigidity of classful addressing schemes. So we started the siderized addressing, classless interdomain routing, and in which we have this approach of arbitrary length. So we have the subnet portion of arbitrary length. Basically, it's very simple. The whole address space was open actually. So there is no concept of classes. I mean, there is no need that a company decide which class address it has to buy depending upon its own requirement, and whether it's if it is a medium-sized company, it has to buy a class B address and waste a lot of address space. But instead of doing all these things, what we started doing was that we have a subnet portion of arbitrary length, and the address they started taking the form of this form a.b.c.d/x, where a.b.c.d are the first four octets, are the four octets of the IP addresses, slash the number after the slash, this x, it represents the subnet portion, okay, the subnet portion of the address, and this can be of the arbitrary length, okay. And obviously depending upon this arbitrary length, we can have a whole set of possibilities, okay. There were two rules which must be taken into account when we want to assign addresses, and these two rules are that the number of addresses in the block, so the block size basically, must be the power of 2. Obviously we have to follow this rule. It's we are dealing in binary. And the second thing is that the beginning address of must be evenly divisible by the number of addresses, and this rule is important. This rule is important because if we don't follow this rule, then the process of masking cannot take place, which is very important. It is very, very important because masking is the process which is being used by routers around the world to find the network address. So otherwise, obviously, we have to store all the possible destinations, and the router tables, they will start to blow up. Not possible, obviously, because the lookup will take immense amount of time. But with the process of masking, the lookup do not take that much time, and for that we need to have all this rule being taken care of as well. Okay. So if, for example, if a block contains 4 addresses, the starting address must be divisible by 4. If a block contains 256 addresses, we need only to check the rightmost byte. And if a block contains more than 256 addresses, you guys must remember the example as well. There was one example in which there were more than 256 addresses. Then we need to check not only the rightmost byte, the last octet, but also the byte before that. So the third octet as well. So then we saw some examples. These examples are taken from Where Was I Frozen? And I mean, we have discussed these. So which of the following can be the beginning addresses of a block that contains 16 addresses? It must be divisible by 16, this and right answer. Which of the following can be the beginning address of a block that contains 1024? Now this is greater than the number of addresses that can be available in one octet. So we need to look at the two rightmost bytes, and so obviously the fourth octet, the rightmost byte, and the second rightmost byte, the third octet as well. So this address is not possible because the last octet must be 0, and so only the one of these can be the right answer, and also this is wrong answer because the third byte should be divisible by 4, and that the reason behind that is that 1024 is 2 raised power 10. So 2 raised power 10 means two bits from the third rightmost byte from the third octet, and 8 bits from the last octet from the fourth byte. So this means that it must be .0 and something which is divisible by 4. So only this address is fulfill these requirements. And then another one was, we have an example of a small organization in which is given this beginning address and prefix. And what is the range of the block? So obviously /29 means that there are only 3 bits in the suffix portion, and 3 bits in the suffix portions means that 2 raised power 3, 8 addresses are there in the total block. So 8 addresses, 24 included, we add 7. So this is the block size, okay? And we can do that in binary as well, like this, okay? Then there was this another example which we also did in the last lecture, and that was that what is the network address if one of the addresses is
इसका क्या
this.
सीन है? वो 7 बजे तक डिलीवर करेगी, उसने पूरा
Okay. So this involves the process of masking. Okay, we are given one address, and obviously with this /27 we can find the subnet mask. The subnet mask contains 27 ones, and 27 ones means 255.255.255.224 in the subnet mask. And then when we perform the logical AND, we will find the address, and this is the network address to which this subnet belongs. Okay. This was the recap from lecture from the previous week, and now let's continue our discussion. This is the question where our time was up, and I encouraged you guys to solve it by yourself. Obviously, the slides were uploaded, but I really wanted you to try it by yourself. So obviously, it's not a FTF mode. I cannot see the show of hands. You can show hands here as well in the Microsoft Teams, but I mean, I hope many of you must have tried this, okay? Provided the fact that obviously we have a quiz planned from from IP addressing this week, tomorrow, inshallah. So have you guys done it? I will quickly go through it. I will not solve it on whiteboard because I would have done it, but I will do another example, okay? So to make sure that even if someone didn't get this one, they will have another example to understand things, and if someone got this one, they will have something new to have a look at it. And obviously, I will just discuss this example on the slides, okay? So uh, you guys have done it, right? Many of you have done it. Is that the case, G? Okay, show of hands. Show of hands. Are there many? Okay, that's good. 5, 6. Good, 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 good. That's good. Okay, perfect. प्लीज जिस जिसने भी किया है सब शो ऑफ हैंड करें. ओके ओके ओके. So a lot of you have done it. That's good. Happy to know it. Thank you, Ji. Then I think it's fair to just go through it on slides, okay? But very quickly, just to make sure that still there are like 15 to 20 show of hands, but if the rest half they have done it and maybe there were some confusions, let's just go through it and try to clear it. So ISP is granted a block of addresses. Addresses starting with, this is the starting address of the ISP, and obviously we know that the total block is quite huge. Okay, so /16 means that this is our X, okay, and X means that our this is our prefix, and the suffix will be 32 minus X, which will be 16. Okay, 32 minus 16 is 16. So the total number of addresses is 2 raised to the power the number of bits of the number of suffix, the 2 raised to the power suffix, or you can say 2 raised to the power number of host ID bits, which is 16, and which means that our total address is quite a lot, 65,000, I think 536, something like that. Okay. This is the whole total number of addresses. Now, obviously, we have already built a rationale that subnetting is required. Subnetting is important to have network, under your control, and obviously divide it into manageable chunks. And obviously for an ISP, because it is doing business with this block, it has many potential customers, and the customers will require, uh, a range of IP addresses. So obviously, according to their requirement, the ISP inevitably has to perform the process of subnetting. Okay, so but what is the requirement? So the ISP has distributed its potential customers into three groups. Okay, so three groups. ISP has distributed the addresses into three groups of customers. First is the customer, which is, you can say, okay, let's assume this ISP is Niatel. Okay, this ISP is Niatel. Okay, and Niatel has a market to capture in Islamabad probably. Okay, and there are 64 customers, so 64 companies in Islamabad, the Rawalpindi region, which are relatively bigger size companies, and these companies require 256 addresses. Okay, and then obviously there is a second group which are relatively small, medium-sized companies, small compared to this one, large compared to this one. They require that many addresses in the third group, which 128 customers. So networking in the networking language, these are basically 64, not 64 customers, but 64 subnets, and each subnet require 256 addresses, and these are 128 subnetworks, and each subnetwork require 128 addresses, and these are 128 subnetworks, and each subnetwork requires 64 addresses. Okay, so we need to design all the sub blocks, means all the subnets, and we need to give the dotted slash notation of each subblock, and then obviously after allocation we need to find how many addresses are left. I have a chat message. Okay, Hamza, I will address this. Okay, thank you for your question. I will address this. I will address this. Right. In this example, there is no wastage, by the way. In this example, there is absolutely no wastage of IP addresses. Okay, but I will create an example after this on whiteboard, and I will explain you guys that when there is a possibility of IP address wastage. Okay. Okay. Right. So, okay, Ji. So let's go ahead. Let's do the allocation for group one. Okay. Sorry, Ji, for those who have done it. I'm grateful. You guys have done well. So thumbs up. Thank you. But just going through it very quickly. You can validate your solution, and the others, who have any confusion can follow it up. So. So group one is 120 64 customers, each require 256 addresses. Okay, so we will design the subnet customer by customer. And one important thing which I want to mention is that in the classful, this is important. In the classful addressing, we approach the problem from how do I say, in terms of an IP address, from left to right. We approach the problem from left to right, which means that we see how many subnets are required, and we borrow that many bits from the host ID portion. I hope you guys remember this. Okay, in the classful addressing, that's how we approach the problem. Okay, so just quickly, trying to remind you how we approach the problem. So a company needs 6 subnets. So we say, okay, 6 is not a power of 2. The next power of 2 is 8, and for 8 we require 3 bits. So we need to sacrifice 3 bits from the host ID portion. This was the approach taken in the classful addressing. In the classless addressing, we approach the problem from not from left to right, but from right to left in terms of an IP address, which means that we want to leave exactly that much amount of bits, which is the requirement of, which is the per subnet requirement. Okay, which is the per subnet requirement. So we, instead of adding the number of subnets, you see, if this, so for those who have done this, let me just complicate the discussion. If this is a classful example, and someone would have given you, instead of this /16, the question was that is something like that. This is not here. The question is that the company is granted a class B address 190.100.0.0. a class B, this is a class B address by the way, 190, because it is smaller than 192. Okay, so this is the range of class B. 190.100.0.0 is a class B address. This is class B. Okay, so if someone has given the problem in the classful manner, what would we be doing? That we would be adding 64 plus 128 plus 128. This is the total number of subnets. Okay, and we would be adding this like 256 plus I don't know, this plus this plus this. Anyone good in math? 312, right? Am I right or not? No, not 312. Um, 128, 256 plus, come on,
320, sir.
320, 320. Okay, so 320. So for 320 subnets, how many bits are required from the? We have a host ID portion of 16 bits over here. This is our host ID portion. It's a class B address. A class B address has a default mask of 255.255.0.0. So we have 16 bit in the network ID, 16 bit in the host ID, and this is a rigid address, not no arbitrary length of no arbitrary length of prefixes are allowed. Okay, it's a weird thing to suppose and discuss in 2021, but this was what used to happen in the early days of internet. Okay, so I'm just trying to convince you guys that why CIDR addressing are important is important over here. So for 320 is we require 9 bits, okay, to address, and we will be having 512 subnets with 9 bits. So we will be borrowing this entire octet and 1 bit from this octet, which means that we will be having 512 subnets and only 7 bits are left in the host ID over here, 1 2 3 4 5 6 7, which means each of the 512 subnets will have 2 raised power 7 addresses, which means 128 addresses. That means that this problem is not solvable with classful addressing. Okay, because 127, well, sorry, 128 is a requirement less than this requirement. Okay, is that we are having more number of subnets, which is not our requirement right now. And coming back to the question of IP wastage from Hamza, I believe Hamza it was, right? Um, this is how classful addressing will not only will not only fail in fulfilling your requirement, but will also waste a huge amount of IP addresses. So anyway, back to our problem. In our case, we will be approaching the thing from the point of view of how much addresses are being demanded, which means from right to left. Okay, so we will just leave that many bits which are required in the host ID portion. Okay, so that's why you see when we are giving addresses to group 1, we are checking what in this group each customer need 256 addresses. Okay, so for 256 addresses, let me just leave 8 bits for the network for the host ID portion. Okay, the suffix length of 8 bits is enough because 2 raised power 8 is 256, which is the requirement of all customers in this group. Okay, and then this means that my prefix will be obviously 32 minus suffix is your prefix. So sorry, 32 minus 8 is 24. This is your prefix, and well, this means that you are addressing when you will be designing the sub blocks, the subnets. It will be something like that. So your first customer in this group, in group 1, your first customer will be from .0.0 up until .0.255. Okay, and obviously /24 is here because that's the prefix. Okay, and then you have consumed all the address range of this .0, because this .0, one shift or one movement in the third byte means 256 movements in the fourth byte. So this is the amount of addresses required, and obviously for the next subnet you will have to you have consumed all the 256 addresses in the fourth byte, in the rightmost byte. Now you will have to make a change in the third byte. Okay, so .1.0 up until .1.255, and then the third customer .2.0, and then the 64th customer .63.0, because 0 is included, okay, for the first customer. So .63.0 up until .63.255. So this is how we will assign addresses to all the customers in group 1. And how many addresses have we assigned? Well, obviously it's shown over here, but this can easily be calculated even from the statement of the question as well. You just multiply number of customers with the number of addresses. 64 times 256 is the total addresses in group 1. 128 times 128 is the total addresses in group 2. 128 times 64 is the total addresses in group 3. And you add all those up and subtract it from 65, 536, you will get the final answer, which is, how many addresses are still available after the allocation. But anyway, we will do it in the proper way. So we have assigned addresses to group 1. Okay. Now let's move to group 2. Now group 2 is 128 customers and each requiring 128 addresses. Okay, 128 customers each requiring 128 addresses. Now again, we will approach the problem in the classless way, the CIDRized way, which is you want to calculate the number of suffix bits required. So for 128 addresses, how much should be the length of suffix?
2 raised to power 7.
2 raised to power 7. So 7 bits are required. The suffix length should be 7, and 2 raised to power 7 is 128. And in that case, your prefix is 32 minus 7, which is 25. So now you have allocated up until 63.255. You will allocate group 2 after that. Okay. So the next address after this address, is this one. Okay. After 63.255, you will have 64.0, the next address, because this is consumed. Now you will have to make a change in the third byte, the third octet. So 64.0, and obviously you start group 2 from this address, and now in group 2 you have 128 addresses for each customer. So in one movement, in one variation of the third byte, you can accommodate two customers actually, one from 0 to 127 and the next one from 128 to 255. Okay, because it's /25, not /24. Okay. Obviously, I'm not going to the detail of performing the binary. I have done it the whole last week, and I hope you guys are understanding. There are 7 bits. So 7 bits means that you are changing the eighth bit, which is the most significant bit of the third byte, and then obviously you are changing the least significant bit of the most significant bit of the fourth byte, and then obviously the least significant bits over here, because /25 means that 8 bits, 8 bits, 8 bits, and then there is 1 bit over here as well. So the remaining 7 is the host ID, which is 2 to the power 7 128. So that means that you can have a case where you have a 0, and then from 0 0 0 0 0 0 0 0 up until 1 1 1 1 1 1 1, and if you check this is dot 0 over here, and if you check this is dot 127, and then you have a case in which you shift this bit. Okay, so you will have a case in which you have a 1 over here, and this is 128 over here, and this is 255 over here. Okay, so you accommodate two customers, and then you make a change in this byte, in the third most byte. Okay, in the third octet. And obviously, in the next third customer would be 65.0 up until 65.127. The fourth customer will be 65.128, 65.255, and up to so on. You can calculate that the 128th customer will be 127.128 up until 127.255. Okay, because you will have 64 movements in the third byte, because within each movement of the third byte you are accommodating two customers, and there are 128 customers, so 128 divided by 2, basically 64. So the 127th customer over here will be having something like 127.0/25 up until 127.127/25, right? ठीक है जी, एग्री कर रहे हैं ना सब? And then 120, after that 127.128, and okay, and this is the total number of addresses. Total 128 customers, each requiring 128 addresses. So let's see, and the third group is this one, which has the suffix length will be 6 bits, because only 64 addresses Again, we are approaching the problem from right to left, as per our requirement, only 64 addresses. And well, in this scenario, we will be requiring 6 bits of suffix, and the remaining 26 is the prefix. And now we will be accommodating four customers within one octet, because now we will be having situation like this: 0 0, and then 1 2 3 4 5 6, and then 1 2 3 4 5 6, and this can go from 0 0 0 0 0 0 up until 1 1 1 1 1 1. And this over here is dot 0, this over here is dot 64 dot 63, and then you will make one change over here. Okay, this is this will be your next subnet. And if you calculate, this is 64 and this is 127, and then you will make this change over here, 10, and then you calculate, this is the top one is 128 and the bottom one is 191. So the next one will be 128.128, the third customer 128.128/26, and then 128.191/26, and the fourth customer again will remain in this 128. Okay, so you accommodate 4 customers in one movement of the third octet, because the requirement is 64. Obviously 64 times 4 is 256, and 256 are the number of addresses in the rightmost octet. Okay ji? Well, okay, so the last address will be something like that. These are the total number of addresses. I've still spent a lot of time. Okay, the total was this. The number of allocated addresses is this one. You can find this by adding this plus this plus this. You have allocated these 3 addresses to the group of customers, 3 group of customers. How many are left? 65,536 minus 40,960. These addresses are still left with the ISP, and you can see that if there is a next requirement come, the ISP will start allocating the address from what will be the next address. If another new requirement come, the next address that the ISP will use to allocate will be 190.100.160.0 onwards. Okay, and it still has addresses up until 190.100.255.255. so still quite a lot of addresses are left. And interesting thing to note is that this requirement was not possible to fulfill with the rigidness of class full addressing if it is a class B address. Okay, so the address space is same, the technique is different, and the technique is quite bad. Okay, but with CIDRized, because we allocate addresses per demand, and per demand means that we calculate suffix instead of calculating the number of bits required to be sacrificed for the number of subnets required. Okay, approaching from left to right instead of approaching from left to right, we approach from right to left. So we calculate our requirement, and then we calculate the bits required in the suffix region. Okay, and then accordingly we have our prefix and we start allocating. Okay, so this is the point where the topic of IP addresses, IP addressing is concluded. As far as slides are concerned.
सर ये इसके बारे में एक सवाल है, ये जो हमने
जी
एग्जांपल
प्लीज
किया
बताइए।
सर ये स्लाइड जरा 11 निकालेंगे।
जी मैं जाता हूँ अभी। ओके, slide 11 right over here। जी yes please।
सर इसकी नहीं जो एग्जांपल अभी की है उसी के बारे में, उसी स्लाइड्स पे।
This is the example that we did right now, slide 11।
जी अभी ये ग्रुप 1 का जो सॉल्यूशन है इससे पिछले स्लाइड, ये 11 है इससे पिछले।
ग्रुप 1 over here, yes। जी प्लीज गो अहेड विद द क्वेश्चन जवाद।
अच्छा सर मैंने ये पूछना है कि जो हम नेक्स्ट कस्टमर नंबर, सॉरी सर।
जी बताइए।
सर मैं वो पूछ रहा हूँ कि जो हम नेक्स्ट कस्टमर पे जाते हैं तो वो हम जो सेकंड जो हमारा बाइट है उससे खुद ही चेंज कर देते हैं या ये रूल है, क्योंकि जो फर्स्ट कस्टमर है उसका तो हमने अकॉर्डिंग टू रूल किया था ना, यानी मास्क के साथ हम उसकी एंडिंग करते हैं, तो वो 0 से 255 होते हैं। तो से आगे हमने जाना है तो हम 1 अपने पास से लिख लेते हैं, या इसकी की है, या आगे जस्ट काउंटिंग करते रहते हैं हम इसे?
अपने पास से कुछ भी नहीं लिख रहे। जस्ट अ मिनट
सर, मतलब पूछना ये चाह रहा हूँ, जो फर्स्ट वाला था, फर्स्ट कस्टमर है, उसका तो हमने कैलकुलेट किया ना, मास्क के साथ उसकी एंडिंग करते हैं और फिर हमें पता चलता है। तो जो सेकंड कस्टमर है और ऑनवर्ड है, उसके हम सेकंड जो बाइट है उसको खुद भी हम कैसे 1 2 3 करते रहते हैं?
अब्दुल्ला, आई एम आस्किंग द क्वेश्चन, आई एम रिप्लाइंग द क्वेश्चन इन उर्दू, ओके? if that is okay with you. So इसमें जो है ना, हम स्टिल बाइनरी में डील कर रहे हैं। मैं सिर्फ मैंने टाइम बचाने के लिए, और ऑब्वियसली अब हम वो बाइनरी वाली जो एग्जांपल्स थी ना, वो समझाने की गर्ज से थी एट द वेरी बिगिनिंग, ठीक है? सो हम उससे आगे निकल चुके हैं। ये हम अपने पास से कुछ भी नहीं कर रहे हैं। ऑब्वियसली इसके बाद जो नेक्स्ट सबनेट बनेगा, क्योंकि इट इज़ समथिंग लाइक दैट, यू नो, हमारा जो टोटल प्लेइंग फील्ड है वो है 190.100 डॉट 1 2 3 4 5 6 7 8 डॉट 1 2 3 4 5 6 7 8। सो ऑब्वियसली 255 का मतलब देखें ये है कि इसमें इसके अंदर एक चेंज, यू सी, व्हेन वी हैव ऑल जीरोज हियर, व्हेन वी हैव ऑल जीरोज हियर, होस्ट आईडी 8 बाइट की है। व्हेन वी हैव ऑल जीरोज, तो हमारे पास जो एक मिनट, जो हमारे पास रेंज हो सकती है वो क्या हो सकती है, डॉट 0 0 0 0 0 0 0 0 से लेके 1 1 1 1 1 1 1 1। तो ये रेंज आपको यहाँ नजर आ रही है, डॉट जीरो के साथ डॉट जीरो और डॉट 255, ठीक है? फिर उसके बाद नेक्स्ट सबनेट क्या होगा? ऑब्वियसली ये रेंज तो फुली कंज्यूम होगी, है ना? तो नेक्स्ट सबनेट इसी में हमें 1 करना पड़ेगा ना। और ये हम आईएसपी की टोटल रेंज के अंदर हैं अभी भी। आईएसपी की टोटल रेंज 0.0 से लेके 255.255 तक है, विच मीन्स आईएसपी की रेंज जब खत्म होगी, जब ये भी सारे वंस होंगे, ये सारे ऑल वंस होंगे, ये भी सारे ऑल वंस होंगे और ये भी सारे ऑल वंस होंगे। तो अभी तो हमने थर्ड मोस्ट, क्योंकि डॉट जीरो के साथ हमारी राइट मोस्ट बाइट फुली कंज्यूम होगी, है ना? तो अब हम सेकंड राइट मोस्ट बाइट में एक चेंज करेंगे। तो हमने इसको 1 किया, अब अगेन 1 के साथ हम 8 जीरोज और 8 वंस, तो ये हमारे पास ये बनेगा। जवाब क्लियर हो रहा है? ठीक है। अपनी तरफ से मतलब नहीं कर रहे ना, स्टिल ये बाइनरी में हम इसको लेके जाके कर सकते हैं।
नहीं,
जी 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 बताइए।
मतलब ये है कि मास्क जो है वो तमाम कस्टमर्स का तो वो सेम ही रहेगा ना, जो हमने शुरू कस्टमर 1 के लिए लिखा था, कस्टमर 2 के लिए भी वही रहेगा। लेकिन मास्क अगर वही रहेगा तो हम जब एंडिंग करेंगे तो हम वो किस एड्रेस की एंडिंग करेंगे?
जो मर्जी,
जो ओरिजिनल एड्रेस है।
बिल्कुल ठीक। नहीं 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 नहीं, मास्क सेम है।
मतलब अपने पास से कौन सा एड्रेस पकड़ के उसकी एंडिंग
कोई
करेंगे?
भी
क्योंकि ओरिजिनल एड्रेस तो नहीं कर सकते ना, वो तो कस्टमर 1 ले गया।
नहीं नहीं, 1 नहीं ले गया, ऐसी बात नहीं है, ऐसी बात नहीं है।
मतलब सर ये जो फर्स्ट एड्रेस है 190.100.00, ठीक है, इससे पुट किया मास्क के साथ एंडिंग की, तो हमें फर्स्ट और लास्ट एड्रेस पता चल गया। अब मास्क तो वही है, अब हम कौन सा एड्रेस पकड़ेंगे सेकंड के लिए एंडिंग करने के लिए, सेकंड कस्टमर और थर्ड कस्टमर्स के लिए?
ओके राइट। सो आप ये कह रहे हैं कि यानी कि अगर कोई एड्रेस आता है जो कि इस रेंज में आता है, फॉर एग्जांपल एक राउटर के ऊपर राउटर के ऊपर एक एड्रेस आया, एक पैकेट आया और उसमें डेस्टिनेशन एड्रेस लिखा हुआ है, लेट्स से 190.100 डॉट आई डोंट नो डॉट, डेस्टिनेशन एड्रेस है 190.100.1.77, सपोज कर लें ये है, ठीक है? अब ये इस हमें देखने से तो पता चल रहा है कि ये इस कस्टमर का नहीं है, ठीक है ना? सपोज कर लें ये नया टेल कर, सो ओके, लेट मी शिफ्ट बैक इनटू इंग्लिश, दिस पार्ट ऑफ द क्वेश्चन इज इंटरेस्टिंग, ओके? So suppose that he is asking that we have a subnet mask which is 255.255.255.0. Jawad, the quick answer is that we will get the correct subnet. There will be no confusion, there is nothing wrong. So if you are thinking that whenever we will be having an address and we will just perform the logical AND, we will perform the process of masking, we will always get this. If you are thinking like that, then that's not the case. So if this is the address, and if we perform the it with the this is the subnet mask. Okay, so subnet mask says 255.255.255.0. If you perform logical AND, you will get 190.100.1.0, which is this. Okay, you will always get correct answer. Have I answered your question, Jawad? And have everyone else understood Jawad's question? So
जी सर, अब सेकंड जो कस्टमर है इसके लिए हम कौन सा एड्रेस पकड़ेंगे?
वी आर नॉट, हम कोई एड्रेस पकड़ नहीं रहे जवाद। एक सबनेटिंग करने के बाद ना एक सबनेट मास्क बनता है /24 के साथ, ये सारों का सबनेट मास्क ये है, ये रहा, सबका सबनेट मास्क ये है। तो कोई भी एड्रेस उठा लें, इसके साथ लॉजिकल एंड करें, करेक्ट नेटवर्क एड्रेस निकलेगा, करेक्ट। ठीक है, अगर ये हो .10.177, आंसर आएगा 190.100.10.0, और ये किसका होगा? यहाँ पे कस्टमर नंबर 11 का होगा। 190.100.10.0/24 से लेके 190.100.10.255/24। व्हाट इज द कंफ्यूजन? मेरी बात समझ आ रही है आपको? ये सबनेट मास्क है, ये दिस ओवर हेयर /24 इज दिस फॉर सब के डॉटेड स्लैश नोटेशन आपको क्या बता रही है? स्लैश के बाद जो लिखा है उससे आप अपना सबनेट मास्क निकाल सकते हैं। इनमें से किसी को भी पिक कर लें, किसी के दरमियान का कोई भी एड्रेस पिक कर लें, जब मास्किंग करेंगे तो आंसर उसका अपना नेटवर्क एड्रेस ही आएगा, उसी सबनेट का अपना नेटवर्क एड्रेस आएगा जब मास्किंग करेंगे। इनमें से किसी को भी पिक कर लें, किसी को भी, कोई भी एड्रेस रैंडमली उठाएं दरमियान में से, जब आप मास्किंग करेंगे तो आंसर उसका अपना नेटवर्क एड्रेस आएगा। सिमिलरली इस केस में भी have I cleared your query, Jawad? Jawad, are you here?
जी सर, अभी थोड़ी कंफ्यूजन है मुझे। जी सर,
Okay,
थोड़ी
then we
कंफ्यूजन
will
अभी
take
भी
it
है
after the class। ब्रेक में लेते हैं फिर। अच्छा चल कंटिन्यू करें। के क्या के क्या, जल्दी से प्लीज बी क्विक, बताइए। Jawad, you want to continue with your question?
नो सर, मैंने कहा है बाद में कर लेंगे ब्रेक।
चलें ठीक है, इसको मैं आप एवरीवन एल्स इज क्लियर विद दिस? या ये जो क्वेश्चन इन्होंने किया था मास्किंग, यहाँ पे जो सबनेट मास्क का डिफॉल्ट वो देखें वैसे हमें ओके, सो स्विच बैक टू इंग्लिश। we although we can see from this 24, this 25 and this 26 that the subnet mask will be same for all the customers in the group, but even if you don't have the visibility of this thing, and if someone just pick a network, and give it to you, then this /26 speaks for itself. It tells you that my subnet mask is 255.255.255.192. Okay, and when if any address comes from this range, and when you perform the logical AND, you will get the correct network address. Okay, I have a chat message. Okay, well Jawad, if this is the case, then the subnet mask will not be different. It can be different. Okay, so the subnetting that is available on our slides is being finished over here. Let me continue. You guys are with me, ji? Continue kare. Let me create an example. So you can have a subnetting question in many different ways. Okay. Let me create an example in which instead of English, the way that we just have our subnetting example just now, instead of English, someone has given us the problem in a pictorial way. So let's assume that someone has provided us with a network with a requirement which is something like that. So let me okay, let's assume that someone has provided us with a requirement which is something like that. Okay, and let's assume that this over here is your finance department, and it require 10 hosts. 10 hosts. Okay, this over here is your research department, and let's say it requires 21 hosts. Okay, and supposedly this over here is your admin department, and this requires, suppose, I don't know, um, let's suppose 5 hosts. Okay, okay, and you are provided an address which is you see which is 200.10.10.0/26. Okay, suppose this is the address that you are provided, and I am asking you guys the question that perform the subnetting. Okay, and perform the subnetting means address this requirement which is shown in the pictorial representation over here, and after addressing the requirement tell me how many addresses are left, if there are any. Suppose this is the question. Okay, so this is one way of asking a subnetting an IP addressing question. One way was what I showed you guys on slide, in which there was an example of a large ISP and 3 customers and 3 blocks of customers. Okay, and we did that. The question was written in plain English. This is the question in which we are given a schematic diagram of network, and someone can give you another way of way of another schematic diagram of the network like this. For example, this is something like that. We have uh, a, a LAN over here in which we have 3 hosts. We have on this interface of router we have a LAN attached, which is which have, I don't know, 1 2 3 4 5 6 7, something like that. Okay, and then another network over here which has, I don't know, some amount of hosts attached. So, and then someone can ask that, okay, you are given a network address of 200.10.10.0 slash, I don't know, let's assume again 26. Perform this subnetting. Okay, so this is now you will calculate your requirement like that you will have this is one of the network, each interface of the router is attached to a different. This is one, and a mistake that the students usually do is that they don't consider this as a separate network. This is one separate network, the point-to-point interface between the 2 routers. So we have these 4 requirements, and then in the slides, the question, everyone is with me, right? This is important. So in the slides, you were given a question in a descriptive way, right? So in plain English, you were given how many addresses are required. But in this example, you are supposed to count your requirement by yourself. So how many addresses are required? Now you have to be very careful, because you will have to count actually the number of host addresses. Okay, and for instance, if you notice, in this case, you require one address for this host, one address for this host, one address for this host, and one address for the router interface as well. Okay, so 4 addresses. There are 4 interfaces, 3 interfaces attached to 3 hosts, and one interface attached to this router on this LAN side of the network. Okay, and because if you remember, the first thing that I discussed when I started the topic of IP addressing is that IP addresses are assigned to interfaces, not to two devices. So this router, if anyone is still in a confusion that this router will be assigned one IP address, that's not the case. Okay, each interface of the router will be assigned a different IP address. So this one different, this one different, this one different, and this router has two interfaces, one over here and one over here. Okay, so the requirement is let's calculate the requirement. Let's call it subnet 1, let's call it subnet 2, let's call this one subnet 3. Okay, S3 and S2 and S1 and S4. Okay, so first we calculate the requirement. Okay, because in our slide example the requirement was given. Okay, in this example the requirement is not given. You are given a pictorial representation. Okay, so I can say in exam that a schematic diagram of network is shown below and the address is this. That's it, do the addressing. Okay, so the description will be short and the question will be in the form of the diagram. Okay, while in the slide example the description was very long and there was no network diagram shown to you guys. Okay, so the requirement will have to be calculated. So one interface, two interface, three interface, four interface, and then each network must have a network address and a broadcast address. Okay, we know that we need two more. You remember I told you guys that we need the number of usable addresses is total number of addresses minus 2, and minus 2 because we need two addresses, one for the network and one for the broadcast. Okay, so the total requirement will be 4 plus 2. Okay, so I let me write just one time. Okay, after that I will just write numbers. So 3 addresses for host, 3 host addresses plus 1 router interface address plus 1 network address plus 1 broadcast address. Okay, that's the total requirement. Okay, which is 6, right? And okay, let's not go into the suffix part right now, but we know that for 6 how many bits of suffix are required for 6? If the requirement is 6, if we need 6 addresses, then how many bits in suffix?
3, sir.
3.
3 bits will be required because the next power of 2 is 8. Okay, but before moving that, let's calculate the requirement of each and every one. So you guys tell me what will be the requirement of subnet 2? Subnet 2. Yes.
4, sir.
Subnet 2 is this one. Oh, okay, sorry. So you cannot see my finger. Subnet 2 is this one. I need pointer. Subnet 2 is this one. This is a subnet 2. I'm calling this subnet 2. What is the requirement? How many host addresses? 1 host, 2 hosts, 3, 4, 5, 6, 7 hosts. 7 hosts. 7 host addresses are required. 1 address is required for this interface of the router. Okay. So 8 addresses plus 1 network plus 1 broadcast. Total requirement is
10.
10
10, sir.
addresses.
10.
10 addresses. Okay, 10 addresses. And calculate for subnet 3G.
6.
6 addresses. Okay, requirement is 6. And subnet 4G.
4. So 2.
2,
4
sir.
addresses. Even this point to point address will have um, a network address and a broadcast address. Okay, even this point to point address of router. Only 2 addresses is not correct. Okay, so even in this case the requirement is 4, right? So 4 addresses. One address for this interface of the router, one address for this interface of the router, and one address for the broadcast and one address for the network. Okay, it may seem weird, but that is the case. Okay, right. So we have our requirements being chalked out, and now one golden rule. Okay, we studied 2 golden rules. The number of addresses must be in the power of 2, and the size of the beginning address must be evenly divisible by the block size, by the number of addresses. And the third rule is that always start from the biggest requirement, from the largest requirement. Okay, always start from the largest requirement. Which is the largest requirement? Subnet 1, 2, 3 or 4?
2 sir.
2.
Subnet 2.
2.
Okay, let me solve it correctly. I will start with subnet 2 and then I will show you guys what could be the what could have been the problem if I would have not followed this golden rule, and I would have just started, you know, in sequence, maybe from first 1 and then 2 and then 3 and then 4, or maybe, you know, in any haphazard random order. Okay, let me do that. Okay, so this is my address. No, why should I do that? You guys do it. You guys do it. Go ahead. This is important. Practice is important. In subnetting, practice makes the man slash woman perfect. Please do it. I'm giving you guys 2 minutes. I cannot waste a lot of lectures time. Must have pen and paper with you. It will be helpful for you. Okay, do it yourself.
सर इसके लिए N4 आएगा
बिल्कुल ठीक. सफिक्स जो है वो 4 होगा. ठीक है जी.
और प्रीफिक्स जो है वो 28 हो जाएगा.
बिल्कुल ठीक है. 28 हो जाएगा. which means this is the address that we have bought. This is the address that we have bought. The total range of this address is, you know, /26 means we have 6 bits in the host ID. So the total range that we have bought is from .0 up until .63. Right? Everyone agrees, right? The total range, this is, you know, this basically means that suffix is 6 bits. So 2 raised power 6 means 264 addresses. With 0 included, we have .0 up until .63. This is the total range that we have bought. And we have to allocate all the addresses of subnet 1, 2, 3 and 4 within 0 to 63. So the first subnet that we are going to solve, that we are going to address, is the largest requirement, which is subnet 2. And subnet 2 says, you know, I require 10 addresses. Suffix will be, because the next power of 2 is 16. 10 is not a power of 2, and for 16 we need 4 bits, and 4 means that host ID will be 4 bits and our prefix is 28. So this means that our range will be, I will not write in binary. I hope now we have done enough of IP addressing. So all of you who have solved it will agree that the answer will be 200.10.10.0 up until G.
200.10.10.16 sir.
Not 16.
15.
15. Okay.
15 sir, yes.
/28/28. Right? Okay. And then if you perform for the next requirement, what would be the next requirement?
6.
Subnet 1 and subnet 3 both are equal. You doesn't matter. You solve one over the other. So continue doing it, G. Please finish your answer. This should just take, you know, 30 more seconds to solve it. Subnet 1 and then 3 and then 4. I don't have space on this slide. If I move the slide, the example will not be visible.
फिर सबनेट 2 16 से 23 तक.
बिल्कुल ठीक. Correct जी. Subnet 2. I will just write a short answer over here because I don't have space on this slide.
फिर बाकी भी सेम चलेंगे. फिर 8 24 से 31 और आगे 32 से 39.
No, the last one will be from 32 to 35, not 39. This is only 4 is required. Okay. So let me just write a short answer. Short answer is always this one. Short answer is, this is /29. This is also /29. This is /30. Okay. And this is /28. We have already solved it. Right, Ji? Everyone agrees? ठीक है जी? This is subnet 2 is /28. Okay. This is /29. This is /29 and this is /30. Okay. Now let's let's do it in a let's forget about the golden rule and let's try to make a mistake, okay? And if I say that instead of following the rule, what would have happened? I mean, most of you would have already understood that why we want to start from the large requirement. I hope most of you have already understood. So let's say that I don't solve it this way and not this and not this. Well, I don't have to erase this because the slash notation will still remain the same, even without following the rule. So this was a mistake. Let me draw it again. Okay, first I need to draw this, and let me write. Okay. Now what I'm doing wrong, I should write with the with green one. Okay, but anyway, this is not wrong. This
सर
is
ये
correct. Slash 29 slash 28 slash 30 slash 28. This is correct. This will remain the same. There is nothing wrong here. 29, sorry, 29. There is nothing wrong here. Okay. Yes, please. Any question?
सर ये आपने लिखा है +1 NA, NA stands for
Network address.
okay sir.
Okay, let me do it in a wrong way. Let's suppose I started from, instead of the largest requirement, I started in sequence subnet 1. Again, can anyone do it and tell me what would have been wrong? If you start from subnet 1, your requirement is what? Gee, keep unmuting your mic and keep saying so that I know you guys are with me. Your requirement is 6, suffix is
3.
3 sir.
prefix is
3.
29
29.
sir.
Starting address?
29.
Starting address?
10.0.
10.0.
Up until?
10.7.
Okay. Next requirement is, let's suppose if we although we can still make it right by by doing the next one as subnet 3, but let's suppose now after subnet 1 we want to solve subnet 2. Do it. So now solve for subnet 2. Oh no, sorry. Please solve for
आवाज
subnet.
इधर ऐसा करो, मैं उधर माइक खोलने लगी, तुम उधर बजा मारती हो.
Please solve for subnet 2. Yes, the requirement is same, 10 addresses, the suffix is same, 4, the prefix is same, 28. There is nothing wrong, there is nothing changed over here, but the starting address will be what? Yes, G. What will be the starting address? Anyone?
0.8.
Okay, so 200.10.10.8, right? The starting address will be right after this one, 200.10.10.8 slash 28. Is that correct? Is it correct? Can we do something like that?
सर होस्ट एंड नेट आईडी फिर चेंज होंगे, इस वजह से इनकरेक्ट है.
होस्ट एंड नेट आईडी चेंज होंगे, क्या मतलब?
लाइक जो प्रीफिक्स है 28 एंड 29 रिड्यूस या हो रहे हैं, मतलब इंक्रीज करना चाहिए,
sir.
वो वापस कम हो रहे हैं.
नहीं, दैट्स नॉट द केस. इंक्रीज रिड्यूस का मसला नहीं है. I mean,
beginning address divisible नहीं है.
yes, the beginning address is not divisible by the size of the block. Okay, who is this? किसने आंसर किया? The beginning address is 8. कौन है जी?
Afira sir.
Okay, Afira, good. Shabash. The beginning address is 8. It is not divisible by the size of the block. The size of the block is 16. Okay, so that is why it is important to follow the rule. Although many of you can think of a notorious way to counter my argument that instead of going for subnet 2, let's solve subnet 3 first, and in case of subnet 3 I can start from slash dot 8 slash 29, and now it is all good, and then I can go up until dot 15 slash 29, and then I will go for subnet 2. But but the golden rule is important, because it is important because uh, sometimes you will not have a luxury like this, and in that case you will be wasting addresses. Okay, so for instance, let's say after dot 15 you suppose you addresses subnet 4, and then you say that 200.10.10.16/30. This is for the point-to-point router network up until 200.10.10.19/30. And now if you want to assign to subnet 2, again it will be wrong, because this is a small requirement. This requirement was only of 4 addresses. Suffix was only 2 bits and prefix was 30. And because you did that, this is subnet 4. The next requirement, which is subnet 2, will be now again a problem for you, because you will be giving address dot 20 10.20/28. Now this is wrong. Okay, you cannot do that, uh, because the beginning address is not evenly divisible by the size of the block. Okay, because for subnet 2 your requirement is 16, your suffix is 4, and your prefix is 28. Okay, so what you will have to do, you will have to waste some addresses over here, and you will have to go up until 10.32/28. Okay, 200.10.10.32/20 up until 200.10.10.47/28. Okay, this means that from 21 up until 31, these are the addresses being wasted. Okay, because of the rule. And this rule is important, the beginning address, because if you do something like that, masking won't work. Okay, if you do something like that and then you will perform the process of masking, /28 means 255.255.255 slash, I don't know, 240, and then you will do the masking, you will not get the starting address correctly. This is a starting address which is wrong. You will always get a starting address of 10.16, which is not the network address. Okay, you have assigned the network address of this one, which is, as I said, wrong. Okay, so you will have to either do it like that, and you will have to waste this range. Okay, so that is why you always start from, sorry ji, you always start from the largest requirement first. Okay, right ji.
लार्जेस्ट
So
रिक्वायरमेंट से स्टार्ट करते हैं तो फिर हमें देखने की ज़रूरत नहीं है कि ये हमारा जो डिविजिबल वाला रूल है वो फॉलो हो रहा है या नहीं, वो डेफिनेटली होगा।
no, it's not definite. You still have to see that. You still have to see that. ठीक है, but it will be easy to follow that rule, because large requirement is divisible by there can be. Okay, so let me go to another empty slide. Let me give you an example. Suppose there is a requirement of 40 addresses in a subnet. Okay, 40 addresses. And suppose there is another requirement of I don't know, 70 addresses in another subnet. Okay, now if you and there is a requirement of, let's suppose, 10 addresses. So there are 3 subnets. Let me give you another example, and instead of picture I'm just giving you a requirement. So suppose there was a picture like this one. Okay, and you can see that we can calculate the requirement, right? 10 hosts plus 1 for this interface plus 1 network plus 1 broadcast. So the requirement over here is 13 addresses. Okay, and the requirement for this network is 13 addresses. For this network is 21 plus 1 plus 1 plus 1 24 addresses. For this one it's 2 plus 1 plus 1 4 addresses, and for this one 5 plus 1 plus 1 plus 1 is 8 addresses. So uh, let's assume that I, instead of picture, I am just giving you the requirement like this. Okay, now we know, and let's assume that our starting address is 200 dot, again 10.10.0, but not /26, but let's say /24. Okay, now as I said that continuing to your question, uh, will it be definitive that if we allocate the largest requirement first, it will be always be divisible, so we don't have to take care of that rule? That is not the case, but it is easy to have that rule, because 70 means next power of 2 is 128. Okay, and 128 addresses means, now this is, you see, if you don't follow a rule here, this rule of addressing the largest requirement first here, you cannot do the addressing actually. Why? Because let's see, 128 means that 128 means that you require 7 bits in the suffix, right? You require 7 bits in the suffix.
Yes.
Okay, so this basically means that 128 is either divisible by 0 or by 128. Over here 40 means, the next power is 64, which means 6 bits. Now 64 is either divisible by 0 or by 64 or by 128 or by 192. On the other hand, this means, this 10 means you will require 16 and 4 bits of suffix, which is divisible by 0, by 16, by 32, by 48, by 64, and up until many addresses up until 240. So the point of taking largest requirement first is simply this one. It's right here. You will have very few options for larger requirements, okay? And you will have more options for smaller requirements. So if you address smaller requirement first, you might have to waste some addresses in the middle to reach to the next available number for the largest requirement. Is it clear to everyone now? That is the reason. Okay, and on the other hand, most likely you will be by following this rule, you will be most likely addressing the second rule as well, which is that the beginning address must be evenly divisible. So you will be most likely doing that. Okay, is it clear, ji, everyone? I have chat messages. No, that's my WhatsApp. Sorry, ji. Acha ji. I think I can skip this example. You can do it right now by yourself, and so this you can perform this example by yourself if you want, right? Would you like to do it, or you think that everything is crystal clear? So then we can just skip it and move ahead.
कर लेते हैं सर.
Want to do it? Okay, then
Yes, sir.
I should stop recording because it's getting very long. And should we continue or should we take a break? Because it's already, sorry, I didn't get a note of the time. It's already 7:15. So I'm going to stop recording, and we can have a short break. Okay.